All right, so yesterday we kind of started this, but what's worth noting is this distribution T is the sum of two random variables. Okay, it's what we got on spinner A and what we plus what we got on spinner B. Is everybody with me so far? And so I don't know about you guys, but that whole tree diagram and all that kind of stuff that we did, I don't want to have to do that a bunch because that was kind of tedious. Are you guys with me that that was pretty tedious? Mm-hmm. So are there ways we can get to this like mean and standard deviation without having to do that whole tree diagram process and everything, so it's a little bit less tedious? That's the intention here, okay? So a real quick reminder that the mean of distribution A was 4.75 and the standard deviation was 5. And the mean of distribution B was 12 and the standard deviation was 12. So looking at this, okay, if we look at this, are we comfortable guessing how you can, once we add two variables, how we can figure out what the mean of a new variable would be? So this 16.75 is the new variable. Are we comfortable with how we got there? How that just kind of happened? Yeah, you could just do 4.75 plus 12, and that equals our new mean. Lovely. Does the same rule exist for our standard deviation? Like 5 plus 12, is that equal to 13? No. But, does anything jump out at you guys there? Do those numbers, 5, 12, and 13, they look kind of familiar? Bet they do to you. Yeah. Yeah. Guys, 5 squared plus 12 squared equals 13 squared. It's a Pythagorean triple. Is everybody with me? Like when we did, if I know this was 5 and this was 12, this would automatically be 13. It's a 5, 12, 13 triangle. Okay, Pythagorean triple is just, it comes out as whole numbers. So, in other words, this 13 is equal to the square root of the 5 squared and the 12 squared. So guys, hear me out. What does standard deviation mean?
The rate, or like the spread.
The spread, it's average distance from the mean, yes? Okay, so it's all about distance between points, yeah? I'd like to remind you of a different formula that is also related to distance. Is everybody with me? That's our distance formula from way, way, way back when. Okay? So here's what I need you to get. Standard deviation is always the square root of squares being added together. Okay, it is always some sort of square root of squares. Like even if we go back to Pete and his Jeep tours, and when we calculated the standard deviation for Pete, what we did was our first outcome minus the mean squared times the probability for that one, plus, so a square being added, a square being added. So anytime we're doing standard deviation, we're squaring stuff and adding it together and then taking a square root anytime. Is everybody good? Now, let's talk about this. And of course, I deleted the tree No, I didn't. So if I'm making distribution G, which I'm going to kind of do on this page just so that we can see everything here, guys, okay? If I do B minus A, I'm going to do essentially the second number minus the first number. Is everybody okay with this? And so the second number, so 0 minus 0 would be 0, 8 minus 0 would be 8, 40 minus 0 would be 40. My next step would be 0 minus 7 is negative 7. Uh, 8 minus 7 is 1. 40 minus 7 is 33. And then 0 minus 16 would be negative 16. 8 minus 16 is negative 8. 40 minus 16 is 24. Is everybody good? And this would be totally something Gertie would do because she would want to make sure she would want to win, especially if there's treats involved. She'll do anything for a treat. So, now, are you guys with me that the probabilities would be the same as they were yesterday? Mm-hmm. So this would be 0.045, this would be 0.3375, I think it was 0.0675.
Yeah.
And then 0.045, 0.3375, 0.0675, exact same probabilities. And then 0.01. 0.075, 0.045.
No.
1.5. I screwed it up in the afternoon yesterday because I put the wrong probability in, and then I just said, don't screw it up like you did yesterday, and then you know what I did? I screwed it up like I did yesterday.
What's under 8? The same as yesterday?
0.3, yeah, all of the probabilities would be identical to yesterday's. All right. Now, so this distribution up here, this G distribution is equal to B minus A. And we already said that the mean of B was 12 and the mean of A was 4.75. Does anybody want to guess what the mean of G is? Or I tell you what, just for kicks to prove my point, because you're not going to believe me. Can we throw this one in our calculator one last time? The probabilities are probably still there, so you just need to change the outcomes, right? Because since they're the same probabilities from yesterday, the probability should still be in your L2, yeah? Maybe?
Mm-hmm. Yeah. It was 8.45.
It's 8.45?
Mm-hmm.
And the standard deviation?
12.26.
Are you sure? 8.25 I would buy.
8.45.
Oh, then you got something wrong.
Okay.
One of your numbers isn't in correctly. It should be 8.25. Make sure your negatives were both negative. Or all three were negative.
Yeah.
Mean is 7.25.
Okay, I'll buy that.
Oh, okay.
And the standard deviation was, huh. That's weird.
That's what I got too.
Is that weird?
Because it's the triple.
The 12 minus 4.75 being 7.25 does not feel weird. So when I subtracted, I know, but I just didn't carry, I just did the minus 0.75 part and knew that it ended in a 0.25. Yeah. Okay, so when I added the distributions, when I added A and B, my standard deviation got bigger. Is everybody with me? Does it make sense that when I have two different distributions, that the standard deviation would go up? Would increase? Yeah. Okay, we said standard deviation measures how spread out a distribution is, yeah? Here's another way of thinking about what that spread really means, okay? Are you with me that when a distribution's super spread out, we have a lot of uncertainty about what's going on? And if your distribution's super close together, there's not a ton of uncertainty. Okay? So, if I have two distributions, do I have more or less uncertainty than if I have one distribution? Do I know what we're going to spin on spin array? There's some uncertainty associated with spin array, yes? Mm-hmm. And that uncertainty is in fact measured by the standard deviation being 5. Okay? Now, when I spin spinner B, do I have more? So I already have the uncertainty. So if I'm doing A plus B, I already have the uncertainty of A. And when I spin spinner B, am I going to end up with more uncertainty or less uncertainty? More. Because I have all the uncertainty of A, and now I'm bringing in this uncertainty of what's going to happen on spinner B. Are we comfortable with that? Mm-hmm. No matter what I do with my result of A and B, do I still have all that uncertainty? Yeah. So if I'm adding my two variables, my standard deviation follows the Pythagorean theorem. If I'm subtracting my two variables, do I still have the uncertainty of A and the uncertainty of B?
Yes.
Yeah. So, as speaking of Indian Gertie, you guys, Gertie is the sneaky dog. You want to know how I know Gertie's the sneaky dog? It'll happen all the time. Indy will be chewing on his chew toy, and Gertie will go bark at the door when nobody is there. Because Indy is a protector dog. Like, that's his personality. So when she barks at the door, he jumps and goes and barks at the door, and then she swoops in and steals his toy. And this happens once or twice a week. And Indy, God love him, is such a sweet pup, but he dumb. You know what I'm saying? Mm-hmm. He's a dumb pup. He can't count to infinity, so maybe it's possible I taught him. 1 twirl, and then 2 twirls, and then when I say infinity, he makes an infinity symbol.
He doesn't sound that dumb.
Yeah, well.
My dogs can't do that.
He's pretty dumb. He also chews on rocks. Like, to the point that he's missing a front tooth. So, like, he dumb. He just likes treats.
Nyla will rile up Allie, start barking and, like, twirling around and, like, getting ready to go outside. So we'll open the door. Allie will run out, and Nyla will get her time by herself.
Yeah. Yeah, that's similar. So Gertie's sneaky. And so what she decided to do was I have an itch. Jeez. All right. She decided that they should subtract their scores instead of add scores. Okay. So now we're going to call this new distribution G. Okay. Everybody with me? And we look at distribution G, the rules for combining distributions. Okay. So we got 7.25 and 13. The answer, does that standard deviation make sense? The answer is going to be yes, because two chance events those events A and events B will have more uncertainty than one of those events. And the big idea there, guys, is that happens regardless of what I do with how many points I got on A and how many points I got on B. So, general rules of thumb is that if I have a total distribution equaling x plus y, then the mean of that total is going to be the mean of x plus the mean of y. Whereas if that total distribution is x minus y, then the mean of the t will be the mean of x minus the mean of y. And for the means, you can follow your intuition all you want. Okay? But for the standard deviations, okay, if I do x plus y, then the standard deviation of t will be the square root of the standard deviation of x squared and the standard deviation of y squared. Pythagorean theorem of statistics. It's always the square root of a sum of squares. And if I do it over here, and what I'm doing is subtracting my two variables, my new standard deviation will be still the sum. So for standard deviations, you always add. But you don't add the standard deviations, you add the squares of those standard deviations, which we call the variance. Okay? Julia, you had your hand up.
For the mean of t equals mean of t minus mean of y, how does that work? Like, how do we know the mean of t already?
I'm saying, so if we're creating a new distribution t that is equal to x minus y, the mean of t will equal whatever the mean of x minus the mean of y is. So you wouldn't. It's like a formula to help you make sense of things.
But it says the mean of t minus the mean of y.
Oh, this is an x.
Oh, okay. Thank you. Okay.
Wait, that's supposed to say x and not t, or?
This one's supposed to be mean of t. This one's supposed to be mean of x.
Okay.
All right.
What's mean of t equals mean of x? What's the thing next?
The mean of x plus the mean of y.
Sorry.
Unless you send new text out, let's see. No, it's not.
All right, we ready? All right. So let's go through an example to kind of make some sense of this. All right. So let's go ahead and say that you have a job working $12 an hour to tutor someone at the elementary school. Okay? And the number of sessions you do in a week kind of changes throughout. So you can either work 1 hour, 2 hours, 3 hours, or 4 hours. And this is our probability distribution. All right, y'all. So what are the mean and the standard deviation of the hours you work?
The mean is 2.3
Okay.
and the standard deviation is 1.1.
Did you do? I didn't. It's okay.
And again, this was the work that you would need to show. Okay.
If there's like under 4 variables, should we just not do the little dot dot?
Yeah.
Okay.
But I do want to point out, you guys, do you see how this standard deviation is a square root of squares and squares and squares being added together? And it's always added. All right. Now, you guys, if you make $12 an hour, are you with me that we could just take our number of hours? We could calculate our earnings by doing 12 times our number of hours. That's what $12 an hour means, yeah? And if I multiply the whole distribution by 12, do I have to redo the mean and the standard deviation the long way, or can we just use those rules of transformations? So what would the mean of my earnings be? If I multiply by 12, is my mean going to change?
Yes.
Is my standard deviation going to change?
Yes.
For multiplying, that answer is yes. So my new mean will be 12 times 2.3. My new standard deviation will be 12 times 1.1. 25, 30, 20,
You almost said it.
25, 36,
Ooh, 27.6.
2760. I think I added with my decimal place in the wrong spot. I did 0.36 instead of 3.6 or something. And then 13.2. But again, this is money, so we're going to call that $13.20. Everybody good? All right. All right, so now let's pretend that you take guitar lessons that cost $8 per session. I'm fairly certain that way underestimates the cost of a guitar lesson. What's the cost of a guitar lesson? 50? Well, just so we know, just so you guys know, I do some private tutoring, and $12 an hour is not what I charge to tutor either. Though at elementary level, I suppose I would charge $12 an hour. I just wouldn't do elementary level and have you guys get hired for it. But let's pretend, okay? Can we pretend? All right, so can we find the mean and standard deviation of the number of sessions? So for the mean, y'all, we would do 0 times 0.4 plus 1 times 0.3 plus 2 times 0.3, which is 0.9 sessions.
I got blue 83.
All right, and let's pretend that those sessions cost $8. What's the mean of my costs going to be? Well, are you guys cool saying that the cost would be 8 times the number of sessions? Also, do you guys notice my use of subscripts here? Like mu S versus mu C versus mu E. Do you think that's done on purpose? Okay. And I believe mu C would be $7.20. And sigma C will be more. $6.64.
How did you get that? Can you explain?
I just did 8 times 0.9 and 8 times 0.83.
Okay.
I mean, now, John, you could take that table above and turn this 0 into a 0, 8, and $16. Right? And then just do it in your calculator again. If there aren't any, you can go ask Mrs. Berlin for some. Is everybody okay?
Where does the point come from? All of the standard deviation.
Huh?
Where does this 0.3?
This
Uh,
is right here.
But like up here as well. Here too. Like what or how do you choose it?
So why did I use...
Oh, okay. Okay. I just didn't make the connection. I see.
You sure?
Yes.
Cool. All right, you guys. All right. So now, at the end of the day, you're saving money. And so you want to know how much are you going to put in savings each week? Like, what are the mean and the standard deviation of your savings? So what we're going to do is take your earnings minus your costs. Does this make sense? So we could we say, try to do that tree diagram thing where we did this, but now it would be 4 branches for the different amount of hours, or for the different amount of earnings. So that would be, let's see, 12, 24, 36, 48. And then for each of these, 0, 8, 16 for my spending. Could we do this? Do you want to? Neither do I. So instead, we can use those rules we kind of just talked about. All right. So the mean of my savings, if my savings are E minus C, okay, earnings minus costs, would be the mean of my earnings minus the mean of my costs. So this is essentially applying those formulas we were just talking about, okay? So we'll take that $27.60 minus $7.20, and on average we are saving $20.40 each week. Give or take, yeah? And give or take how much? Well, my standard deviation of those things will be, I'm gonna have to do that squares things, right? And what sign, if I'm subtracting my earnings minus my costs, what sign goes in between those standard deviations?
Addition.
Always addition. 2 events will always equal more uncertainty. Do you guys see what I'm saying here? Always going to get bigger addition. So we would do the square root of, what was the standard deviation?
13.2 squared.
13.2 squared plus 6.64 squared.
I got 14.78.
Sure.
That was an intense.
And this is a really good place to take our block day break. You guys, all the statistics in this particular question are definitely a lie, because weights are not normally distributed, okay? But we're going to pretend they are. Okay, so let's go ahead and say I have that the weights of men are normally distributed with a mean of 190 and a standard deviation of 30. Okay, so if I call that mu of m equals 190 for men, okay, and sigma m equals 30, okay? If that is the case, I randomly select 2 men. What are the mean and the standard deviation of the sum of their weights? So let's go ahead and call this distribution D for double the weight, I guess.
Okay.
I just know where we're going, okay? And are you guys with me that would be the sum of 2 different men? So if I say, what is the mean of D? Well, if we follow those rules, it would be the mean for the first guy plus the mean for the second guy. But when it's 2 men, when we have M1 and M2, those means are the same. Are we comfortable with this? And are you, if I say, hey, the mean for 1 guy is 190, what's the mean for 2 guys going to be? 390. We'd be good with that, yeah? All right. Can I just double the standard deviation the way I just doubled the mean?
No.
Because I'm not multiplying by 2. I'm adding 2 variables together instead of 2 of the same thing. We don't know that both guys are going to weigh the same. We know the average of the 2 guys will weigh the same. Do you guys see what I'm saying there? So if I want to find the standard deviation of D, I would do the standard deviation for the first guy squared, standard deviation for the second guy squared. You with me? So really I'm taking the square root of 30 squared plus 30 squared. 42.43, sure. All right, so what if I have 3 men? You see why I didn't want to use T for 2 men last time, right? You guys, what's the mean of T going to be? 190 plus 190 plus 190. $570. And the standard deviation of T would be the square root of 30 squared plus 30 squared plus 30 squared. More variables equals more squareds being added together. $51.16?
96.
51.96. Cool.
On like a test, do we have to write out the base equation prior to?
If you have that, you're fine. Like, I think for your own sake, writing out what the variable is, then this, and this, like that would be sufficient.
Okay. Also,
If that's what you mean.
how picky is AP and you on units after?
I've seen units be the reason someone go from an E to a P.
So don't do.
No, because they didn't include the unit. They went from an E to a P. Because units can get you credit for context,
Okay.
right? So I've also seen the subscripts give people credit for context. Sometimes. Sometimes they do and sometimes they don't. So yeah, these should maybe say pounds. All right, so you guys, how many of you rode the elevator in the old building? Okay. You guys, if I want to go ride that elevator and there were more than 2 people in that elevator, I took the stairs. You guys, for those of you who've never been in the elevator that used to be over there, if I were to say janky is too kind a word to describe that elevator, am I lying?
It's like
Yeah, like it was a terrifying elevator experience. Okay, so
bring heavy things down.
So this is what I'm saying. So let's say I come across this elevator and it has a weight limit of 700 pounds. Okay? And I'm a guy. And there's already 2 guys in that elevator. You guys get what I'm saying here? Should I get in? Will 3 men put it over weight limit? What is the probability that happens?
Probably not.
Let's decide. So here's what we're going to do. What do we know about the distribution of the weights of 3 men? Well, we know has a mean of 570, a standard deviation of 51.96, and we know that each of the initial men's weights was normal. So the combined men's weights, also normal. Okay, so when we're dealing with normal distributions, when we combine normal distributions, the answer is also going to be normal. That new distribution will be. All right, so here we go. We got a mean of 570, a standard deviation of 51.96, 700 or more. So what is the probability that the sum of those guys' weights, the sum of 3 men, is greater than 700? This is where you guys become significantly smarter than I am, because I don't feel like bringing up my calculator. So by smarter, I mean more motivated. Does it matter if I do greater than versus greater than or equal to in this setting? Because this is a continuous variable, doesn't matter. Guys, what are we getting? It should be pretty small.
Oh, okay.
You guys, how do I know it's pretty small? So we're talking about 130 pounds above the mean. That's more than 2 standard deviations, yes?
Mm-hmm.
You with me? So it's okay that it's small.
Okay.
0.0 what?
006176.
So you guys, if I see 2 people on it, should I get on that elevator?
Yeah.
Sure. It's fine. It's totally safe. 3 people? Probably not.
Mm-hmm.
Is this okay? All right, there's one more thing that's going to show up here with Carter and Ricky. All right, so here's what we got. The mean for Carter is 105. And the standard deviation for Carter is 10. And this is for how long it takes to do the mowing itself. Okay? And the mean for Ricky is 98. And the standard deviation for Ricky is 5. No. I got lost in my own question. 15. All right, so the question becomes, what we're trying to figure out is, what is the probability that they finish within 5 minutes of each other. So let's start with what mathematical operation do we want to do for finish within 5 minutes of each other? Subtraction. So we're going to come up with a new distribution, D, that is Carter minus Ricky. I could have done this the other direction. It wouldn't have caused any problems. Okay? Now, well, let's just see. What can we say about the mean of distribution D? What will that equal? 105 minus 98, which is 7 minutes. So what does that really mean? On average, they finish 7 minutes apart. Okay? Does that mean they're always going to finish 7 minutes apart? No, some lawns is going to take Ricky longer, sometimes it's going to take Carter longer, right? Right? What is the standard deviation? And when I say what is it, tell me how to find it. Don't tell me what the answer is.
Would it not be, wouldn't it not be standard deviation of D? Why is it Carter?
It's D.
10 squared plus 15 squared. Oh, yeah.
100 plus 225 is 325, so it's going to be 18.0. 18.03. Very similar to the year in which the state of Ohio was founded.
But technically it was
Weird.
definitely
What are your
right,
times?
because they didn't have the correct papers.
It's only a little bit over 200 years. It's really weird.
So you're saying Ohio University is older than the state of Ohio? Technically.
Yeah, technically.
The oldest public university west of the Appalachian Mountains.
I mean, I guess mine has
Okay, y'all. We have done, how many of you feel like this is starting to become like very reasonable for us? Okay. Okay. What is the probability they finish within 5 minutes of each other? This becomes a slightly more complex question than kids think at first. So what does it mean for them to finish within 5 minutes? What would that mean about their difference?
That's less than 5.
That the difference is less than 5. Are you sure?
Less than equal.
Equal
Or
to or
equal
less
to.
than 5.
It's continuous distribution, so it doesn't matter. Could it happen that Carter takes 95 minutes and Ricky takes 101 minutes? Is that a possibility?
Yes.
What would their difference be there?
6.
-6, because we are doing Carter minus Ricky. And did they finish within 5 minutes of each other in this case?
Yes.
No,
No.
definitely not. Okay, so when we do this, okay, and this is like one of the ways the College Board might try and trick you. Not saying that I'm going to pick one of the ways to test you that the College Board would try and trick you, but like when we think this through, in order for them to finish within 5 minutes of each other, it's not their difference that has to be less than 5. Essentially, what needs to happen is the absolute value of their difference has to be less than 5. Another way of saying that, their difference has to be somewhere between -5 and +5. That's what we're trying to find. The probability that their difference is in between -5 and +5. So as we think through this, like, that's the only way I actually see them trying to trick you. Not the only way, but you guys get what I'm saying. I don't know, 10%, 15%,
0.203.
0.20.
That's what I got, but I didn't.
Oh, yeah, I was being stupid. What do you guys think? Is this okay?
Mm-hmm.
What's the top of the next page say?
Intro.
Intro to binomial. That's going to be you.
That's gonna be me.
She's going to teach you guys that on Monday.
You guys excited?
Why don't we start here, guys? Can you guys, that review that you got last week,
Mm-hmm.
why don't we start looking at that? Please and thank you. I think, what would you guys do if I made a game out of the AP Classroom stuff for Thursday?
What do you mean?
And I put you guys on teams and there's like a competition.
Ooh, I would like that.
Sorry to whoever's on my team.
Man, I would let my team down.
Guys, when you're done with that review, what else could you be working on?
Fan correction.
Prioritize the test corrections. Test corrections in that review today.
Can't wait for this week to be over. Oh my god. I wanna go back
You
to
say
like
that.
9
Yeah.
Like,
Did I get another copy?
yeah.
I took a bunch of stuff.
I know, not even wrong.
And then copy some.
Both breakfast and lunch. Where's my adding question?
So excited.